Welcome to our next plenary session. It is my privilege and honor to invite scientist Dr. Mandar Tata, who work beautifully bridging the field-based natural history, ecological theory, and conservation challenges, especially in the world's most fascinating biodiversity hotspot, that is Northern Western Ghats. Today, we are extremely fortunate to have with us Mandar Datas, a distinguished plant ecologist and taxonomist from Agarkar Research Institute, Pune. Dr. Datar holds his PhD from Abasad Perware College, Pune, and MSc and PhD in Botany from Savitribai Phule Pune University. He has made outstanding contribution in the field of plant taxonomy, floristic, endemism, plant nomenclature, field ecology, with special focus on desiccation tolerant plants on rock and cliff dwelling vegetation system. He has published more than 76 research papers in leading international journals such as Nature Communications, Ecological Applications, Basic and Applied Ecology, Phytotaxa, Clause 1. He is a prolific author with 7 authoritative books to his credit, with Forest Foods of Northern Western Ghats, Flora of Bhagwan Mahavir National Park, Manual for Field Botany. Beyond his research, Dr. Datar played a vital role in conservation policy and academic mentoring. He is a nominated member of IUCN SSC Western Plant Specialist Group and a recognized PhD guide at Savitribai Phule Pune University. His work was acknowledged with various prestigious honors: Dr. K.L. Mehta Memorial Award, Kirloskar Vasundhara Samman 2023, a Fellow of Indian Association of Angiosperm Taxonomy. Dr. Datar's commitment to science communication and public outreach has made various popularized books in Marathi, over 250 popular articles, contributed to documentaries, All India radio programs, and his very widely appreciated YouTube channel, Plants, People and Poetry. With this background, I invite and request Dr. Mandar Tata to deliver today's plenary lecture. His talk is From Rock Shelters to Vertical Cities, Lessons from Cliff Ecology.
Thank you very much, Dheeraj. Such a wonderful introduction. I feel proud and privileged to stand and deliver a talk in this heritage building, Gandhi Hall, basically. So, right from the founder member, Dr. Agarkar, we have been working on the medicinal plants of Western Ghat region, especially traditional wisdom, to document traditional wisdom associated with tribal communities of Western Ghat has been our forte. And when I joined, I did my PhD from Botanical Survey of India and Plant Taxonomy, and when I joined Agarkar Research Institute, as I already told you, Gadgil sir influenced me a lot, and I chose a path of an ecologist to go ahead. And then various systems we are trying to study in Western Ghat region. We have studied grasslands. So part of my work was also in Vidarbha. So I visited this Karanjala and Murtizapur and Akola grasslands and studied them in addition to the peripheral grasslands around. 2 systems we are trying to study are vertical cliffs and horizontal lateritic outcrops. And why I feel this vertical cliffs and lateritic outcrop fascinating? Because of the set of adaptations shown by the plant. So in the next few minutes, I try to glimpse you through the wonderful landscapes of the cliff system. But as my title suggests, from ancient shelters to modern skyscrapers, we are trying to look at cliffs. That is perfectly okay. I had no issue with this other thing. So we have been, as a Homo sapiens, our species took our first steps in the savannas of Tanzania, we were called as cavemen. So right from caveman stage till today, we have been helped by cliffs, helped by vertical landscapes. Uh, they have sheltered us over the years, and our whole civilization progressed along the cliffs. And that's why I feel cliff it's a habitat which connects our past and is going to help us in future. That's why my talk is basically connecting the past and connecting the future to our present work, what we are trying to understand in Northern Western Ghats. Cliffs as an ancient center and their role in human civilization. We briefly talk about cliff as a landscape in Northern Western Ghats, past research and research gaps, followed by the approach which we took for our research, that is quantitative approach to ecology. We went ahead with classifying plants as per various plant functional types and try to give you a rationale why we chose this plant functional type classification over any other classification. And then core of our work lies around understanding plant environment relationship. So how, on one side we have biotic factors such as plants, pollinators, animals, and on the other side we have various abiotic factors, weather, climate, all those factors. And through our research we try to establish association or try to see association between these two factors. And then key insights from our research and cliffs and their role in future as we think. So there are two contrasting landscapes I try to put in one side. On the left side you see modern skyscrapers, modern and filled with various modern amenities, and on the other side you see a very ancient cliff ecosystem or cave ecosystem where earlier civilization, earlier people took shelter. And then on one side we have present, on the other side we have future, but again we are associated with the cliffs. So which are sheltered by basaltic cliffs in the northern western Ghats, totally different species in the central and southern western Ghats. So why we attracted towards cliff was because of this person, great person known as Douglas Larson. So he was basically a Canadian and worked in Niagara escarpment, and he was the first person globally to understand this system as a very unique system, very interesting system. And he wrote a book called Cliff Ecology, and where he has defined what is cliff, and the same definition which we follow for our work. So I have been constantly corresponding with Douglas Larson about his ideas. He's still very active, not in the research, but he keeps on reading papers system of Western Ghats. One of them was by this Baruch and Ansari. They were ecologists in this Institute of Science, Bombay, Mumbai. That time it was Bombay. So they wrote a paper, very old paper, I think 1962, but they never used this term cliff because this was adopted in plant ecology after Douglas Larson's famous book. And then there was a fellow called from India, Desiccation tolerant plants. We studied further and took this number to 62. Now, only of the 350 desiccation tolerant plants that are known in the world, majority of them coming from the tropical region, we contribute for 62 species, and I suspect that there will be more than that. If you find in and around Varda also, you get desiccation tolerant plants for sure, but no exploration has ever happened. What is important or what is unique about this Deccan volcanic originated cliffs is it's a stark seasonality. So geomorphologically, as I already told you, they are part of Deccan Trap. It's a escarpment age, so it's a 90-degree fall from the plateau of the hill, and they are basically, the base rock is basalt. But what is important about them is this seasonality, stark seasonality. So they have this complete inundation, 4 months of continuous rainfall, followed by 8 months of dry period. So if you imagine a plant growing on vertical cliffs, it has to get subjected to 4 months of complete rainfall, full rainfall, and then 8 months of desiccation. It's a very challenging process, and that's how plant species of these cliffs have adapted to these extremities. So seasonality is very important. As you move towards, it is the one which dictates the vegetation in northern western Ghats. So we studied these two cliffs, man-made cliffs and natural cliffs. So we adopted this definition by Douglas Larson for our systems. So he says that cliffs are unique habitat with steep overhanging mass of rock, 90-degree vertical drop from the plateau, and its defined physical features are obviously they are exposed to direct sunlight. Since they are exposed to direct sunlight, they are exposed to UV light, and majority of the plant adaptation. If you see a brightly colored flower in the wilder habitat, you can safely assume that it has adaptations against UV. So in addition to providing color for the plant, for pollinator to attract, anthocyanin also helps plants to protect from the damage that is caused by UV radiation. So many brightly colored plants are found in the cliffs or lateritic plateaus because they are exposed to direct UV radiation. And wind is another factor, but wind also helps in seed dispersal. So one factor there that's going negative against them is wind, but that is also helping them because majority of the cliff species are wind dispersed species. But one most important factor that actually shapes the cliff vegetation is geotropism. So if you see, gravity is the factor that normally supports a terrestrial ecosystem. So for forests, for grasslands, for many other tundras or taigas, if you see, gravity holds the system as such. But for the vertical habitat like cliff, it acts as a negative system. So it generally pulls down the species that are growing on the cliffs. And obviously it will bring down the soil. So obviously a nutrient poor habitat. So cliffs, on the cliffs you see limited soil is there, and that's why they are nutrient poor. Whatever nutrients are there on those soils, they will be leached out or washed out due to the consistent rain they are getting. And then it becomes challenging because if a species grows beyond the limit, there are chances that it will directly fall down. So that's more challenging environment than any other habitat. So what approach we took, I'll just briefly summarize. So we, other than just documenting the taxonomic species from the cliffs, that has been happening over the years, people have been documenting species from cliffs. Rather than this taxonomic approach, we did quantify species diversity, abundance and distribution. And for the students who have gone through these ecology classes, they know what is species diversity and how abundance and its distribution, alpha diversity, beta diversity, gamma diversity is calculated, how community ecology is studied. We also analyze this plant environment interactions, and then we use this plant functional type classification for the system, and then examine how plant functional type diversity correlates with environmental and topographic factors as core of our research. So let me go ahead, what methods we used. This was done by my PhD student Smruti, who laid 88 such quadrats. So we had a transect line, this defined transect line on a cliff, because majority of the cliff part is inaccessible. So whatever is accessible, so I kept on telling Smruti that we can do without some species on the cliffs, but we cannot survive, we cannot do your PhD without you. So safety was the most important priority for her. And then whatever accessible areas, and literally it was very difficult for me also as a PhD guide to send students to study cliffs. So when their PhD, all the fieldwork happened, I actually generously gave them party. Normally guides don't give parties, you know it. So because of the safety is the biggest issue. And then Douglas Larson also kept telling me that your priority, number 2 priority should be documenting cliff species, and number 1 priority is zero damage or zero casualties. That's what he kept telling us. So this was the way 6 on a transect line, 6 quadrats were placed, and in each quadrat we will have sub-quadrats, and we will measure the vegetation, what are the species present on the cliffs, and as well as we will document like overall approximately how much percentage of the quadrat surface has been covered by vegetation. These were the sites in northern Western Ghats which we selected for our study. We also divided them into various micro-habitats. So cliff is an ecosystem, or we can call them as a habitat, and those habitats can be further divided into various micro-habitats. Micro-habitats can be cliff edges, can be crevices, can be talus. Whatever matter collected at the bottom of the cliff is called as talus. Then there are consistent waterfalls in Western Ghats cliffs. So that spray zone is also interesting habitat. Then we have various caves and overhangs and ledges around this. So all these microhabitats we try to divide those species. So our approach was identify species, try to group them into these microhabitats and quantify them using ecological methods. So what was the most important thing from these microhabitats is there are species shared between various microhabitats. But despite of that, crevices has the most number of species, which is obviously why this microhabitat shelters more vegetation, because crevices there is a soil, and that soil gives chance for a plant to hold its roots for the anchorage, and there are some species which can grow in these crevices. So then rather than just doing taxonomic work like identifying species in various groups, so there are two approaches normally people have taken in documenting diversity. One of them is taxonomic approach, which is go study systems and identify plants belonging to various families, taxonomic families, and then group them like this family belongs to these many members. But that doesn't necessarily tell us about the ecosystem. So which way, what is the best way that will inform you more about ecosystem is grouping them as per the functional type. So functional type was the first time used by around here. I saw an abstract where somebody has classified group plants from Yavatmal region based on round years life form. It was a good approach. So based on the round life form you group them. So life form is basically resource acquisition based. So how a species demands various resources from a system. Based on that you group them and then you actually get a better picture of an ecosystem than just taxonomy grouping. So based on adaptations and integrated traits, so trait space is again a very interesting concept. I will not go into details of that, but you measure various traits from plants, quantify them, not just document them, you try to quantify them, and then based on that you can construct a trait space for each of these species. And normally this is the ideal example, theoretical example. But if you see cliff system, these trait space, they lie somewhere in the one corner. So then we divided those plants into 7 or 8 functional types as demanded. I will just give you brief ideas about what these plant functional types are there. So rather than just classifying them into plant families, I am repeating this. We are grouping them into resource acquisition based classification. So this is the plant functional type which is known as succulent, and this particular plant is known as Praeria indica, which is the endemic species of northern Western Ghats. And this was considered one of the 12 most threatened species of the global databases once upon a time. Now, like people have found out in various locations and it has lost its status. But for us, this was one of the most threatened plant of the globe occurring in Western Ghats. So why this particular plant is unique is because of its photosynthetic pathway called as CAM. So in theoretical terms, in theory classes, you must have heard about the CAM photosynthetic pathway, which is a unique rather than the C3 pathway. But I think this is globally just second plant who shows mix of photosynthetic pathways. So you can imagine a situation where this Praeria indica, its stems are growing from a clay surface, and the 8 months of 4 months of winter and 4 months of summer, those 8 months will be completely dry. The plant will be surviving despite of all these challenges following a CAM photosynthetic pathway. So theoretically, CAM photosynthetic pathway helps plants to survive in the drier environment without losing water through transpiration. So CAM photosynthetic pathway will help the plant to survive 8 months. So as soon as monsoon is there will be leaves coming out from the plant. Those leaves will be doing normal C3 photosynthetic pathway, and then at the end of monsoon, when they accumulate enough amount of food through process of photosynthesis, then that particular food is utilized for production of flowers, then followed by production of seeds. When the seeds are liberated, the C3 leaves will fall down and the CAM plant will remain on the cliff. So that's how this CAM species or succulent species survive on this cliff. So there are many peculiarities in this. So another example of this CAM plant is this Sarcostemma. Locally, people call this plant as a som plant. So you know, in northern part of Pakistan, that Khyber Pakhtunkhwa region, the real som species, the ephedra from which som was extracted earlier, used to come. But there are many representatives of som plants. Like many plants have been called as som. One of them is this Sarcostemma species, and then Ephedra, for example, the true Ephedra or this Sarcostemma exactly resembles each other, though they belong to different families. So being subjected to same pressure, same environmental pressures, they have adapted in such a way that they resemble each other. So plants belonging to various families look similar. For example, Cactaceae, there is a family called Cactaceae. We don't have wild Cactaceae in India, but all the Euphorbiaceae members, those who follow botany would understand this. Euphorbiaceae members look like cactus. So this is a very interesting tendency shown by plants. So this Ephedra is basically gymnosperm, but all other Ephedra looking plants belonging to different families are also called as so. So this was plant function, one plant functional type which followed this CAM photosynthesis pathway. Another plant functional type was carnivorous. So carnivores belonging to two families majority on leaf surfaces. One is this Lentibulariaceae, a plant called Utricularia or bladderwort, very prominent in Western Ghats. Locally they call his Utricularia genus as Sitace aswe. So there is a story, there is a folklore associated with the species that when Sita was taken up by demon Ravan towards Sri Lanka, she kept on crying, and wherever her tears dropped down, this particular species emerged. That's why it's called as Sitace aswe. And you see the distribution, it's completely Western Ghat specific species. So there is also kind of a support for all these folklores, or while seeing the distribution, people might have named it other way also. But this plant on the cliff surfaces where they are nutrient poor, obviously, shows insectivory. And insectivory is a wonderful adaptation to survive in the hostile and challenging environments of cliffs. There are other examples of such a wonderful looking, beautiful looking plant known as Utricularia striatula. Then another plant functional type which survives well on cliff ecosystem is legumes. So legumes, as you know, have root nodules on their nitrogen fixing bacteria associated with root nodules on their below ground surface, roots basically. And this nitrogen fixing bacteria helps plant to survive, because obviously, as I am again and again insisting, that cliffs are nutrient poor habitats, and for you to survive in the nutrient poor habitats, one such adaptation helps them is the nitrogen fixing bacteria associated legumes. And there are many species. This particular plant is known as Mithia. This is basically a plateau species, but some of the individuals would grow on cliffs. And this is known as Mickey Mouse because the plant exactly looks like Mickey Mouse. Locally, people call it as a kavla because the fresh leaves, the leaves produced before or collected before flowering, are used as a wild vegetable, and that's why kavla is like anything tender. Another plant functional type which we grouped was Graminoid. So Graminoid means all the grasses and cyperaceae members, and why Graminoids are unique or Graminoids are interesting is because their investment into various resources. So they don't normally, plants would invest on a bright color or bright scent to lure the pollinators, to attract the pollinators and lure them. But Graminoids specifically invest in more number of pollens, and for seed dispersal also they used very distinct mechanisms. So their investment strategies, resource strategies are different, and investment strategies into pollination and seed dispersal are very different. That's why they can be grouped together. And many of these grasses are found. In addition to the investment strategies, they have this C4 photosynthetic pathway. So if you see around Vardha, it's okay. So if you see around Vardha, majority of the grasses are C4 pathway, following C4 pathway, because they can survive well in the ambient, if the ambient temperature is higher and moisture is low, C4 grasses can survive. And globally, 65 million years ago, all these grasses evolved, but when the earth was there, 22 million years ago, a period called Miocene. So there is a point in Miocene period called as Miocene optima, where the temperature of the earth was higher. That time grasses evolved an additional photosynthetic mechanism or additional photosynthetic loop known as C4 photosynthetic. So that's why they could survive. So all these graminoids on cliffs follow C4 photosynthetic pathway. I'd say many wonderful images are there. So this particular plant has this inflorescence stalk much longer than any other grasses. That helps them to bury the seeds in the crevices. Another interesting plant functional type is geophyte. Geophyte are the plants which have underground tubers or bulbs, subterranean bulbs. These bulbs or tubers, how they help plants? They store food, and then the above ground biomass dies immediately after monsoon, and then the below ground subterranean biomass only survives the hostile period of winters and summers. And as soon as you get next monsoon, they survive, they sprout from these tubers, and then they have this added advantage because they can utilize last year's stored food for the survival, and from that they sprout and immediately produce flowers and fruits, and they can avoid competitions with other species. So obviously in monsoon everybody tries to flower in the favorable season. There will be competition for pollinators, competition for seed dispersal agent, competition for resources. So how geophytes survive this competition is immediately producing these flowers and fruits. So it's a head start for them because it's a last year stored food, and based on this last year stored food they immediately flower, and rest of the year leaves will remain. They will synthesize food and store in the geophyte, store in the bulb tuber or corm, which can be utilized in the next season. So I keep this telling jokingly that if I had to compete with this Usain Bolt for 100-meter sprint, and if I get a chance to stand at 90 meters, there are chances that I will win because I have a head start. Similarly, they have a head start in the form of stored food of the last year. So many geophytes are there. This is an Aeroidy member. Begonia are very common. Another plant functional type which helps plant to survive is hemicryptophytes. So they are partially parasites. Some of them are totally parasites, some of them are partially parasites. And they survive because of the parasitic mode of nutrition. They can survive well on the cliff habitat. There are very few trees on the cliffs as such, but some plants belonging to ficus can grow. They are lithophytes. They can grow on them. But then, if you approach dendrochronologists, take a section of those cliffs and try to measure the when the plant was established based on the carbon dating. If you take a similar species in the valleys with the same diameter and on the cliffs with the same diameter, normally cliff species are much older than the valley ones, but they have attained the same size as the valley plant because they are again growing in the very hostile and challenging environment. So another plant functional type is normal flowering plants known as therophytes, which we call as escapers, because before the unfavorable season approaches, they finish their life cycle and complete the life cycle and just vanish from the scene. They just liberate their seeds, and those seeds will remain in the soil, and those seeds will survive the dry part of winter and summer and again germinate in the next monsoon. So most important contribution from our lab was this documentation of this desiccation tolerant plants. As I told you, already there are species documented, 9 species documented by Donald Gaff on these cliffs. We took this number to 32, and those species, there's a group, the genus called as Tripogon. So this Tripogon survive on the vertical cliffs, and the same individual leaf will turn brown. As I already briefed you, as soon as they receive the next shower of monsoon, the same leaf will turn green and start living again. So this is coming back from death, and that's why they are called as Sanjeevani. So when I saw this movie, Three Idiots, there was a song by Swanand Kirkire, which goes like this: give me some sunshine, give me some rain, give me another chance to grow once again. So when I heard this, I really thought of desiccation tolerant plants, and I thought Swanand Kirkire might be knowing about this plant, that's why he specifically wrote these lines. So Donald Gaff was a person who documented it, and we took it further. This is a Tripogon lisboi mat growing on cliff, and the same individual is turned brown, and as soon as you take them, put them some water, they will turn green. So we keep doing such experiments, bringing various plants which we suspect as desiccation tolerant plants, bringing them to lab and subjecting them, throwing some water on them, sprinkling water on them, and try to see their response. So the collaborator keeps on telling that you bring plants to a lab and torture them, and that's not the way to do. But then in addition to observations in the field, we have to do some experiments in labs, and we have created a mesocosm kind of a greenhouse where we maintain these individuals. In addition to being desiccation tolerant plants, these species also form a reticulation of mats, networks of mats below ground. So in monsoon, you don't expect that there will be 90 days of continuous rain. There will be some dry spells in between. So to survive those dry spells, what happens is this mat formation is there. So these root mats basically formed by these plants will trap soil, will trap nutrient, will trap humus, and then they will accumulate a lot of water, and this mat will actually act as a sponge during the dry spells within the monsoon, and then those mats help survive this trichoban species. So we named these mats, we wrote a paper globally all across, so right from Africa, India, Madagascar, tropical Africa and South America. They show this mat formation, and we named them as a desiccation tolerant mat forming monocotyledons. This is the life cycle. Normally we kept on, there is a site called Graminoids in close to Pune. Every 15 days we would visit that place and try to see the landscape, how changing and how desiccation tolerant plants are responding. And in addition to that, we'll bring them in the lab and study them. So what, in addition to this, we did was this plant environmental relationship, but I will not talk more on this, but to brief you, what we have done is try to correlate environmental variables of a particular site with what vegetation we have documented, and we could associate certain environmental factors with that. But the important takeaway, if you ask me like what are the one takeaway from our work from cliffs was basically the percentage of the vegetation covered. So globally, whatever cliff systems have been studied by people, Mediterranean limestone cliffs show close to 7.2% of the total surface covered by vegetation. In this dolomite cliffs, they show 5.8% of the surface covered by vegetation. In sandstone cliffs, it was below 10%, but in northern Western Ghats, we found that 41.2% of the cliff surface is covered by vegetation. That is because majority of them belong to this desiccation tolerant mat forming monocotyledons. And why we feel this particular trait of covering the cliff surface, barren rock surfaces is important for future is we are approaching a threat in the form of climate change. And already cliffs have been species have been surviving. Cliff species have been undergoing various hostile environments. So if you measure a temperature of cliff rock, it can go up to 60 degrees in summer. So in those 60 degrees, we actually measured it. So in the 60 degrees of summer, certain species are surviving. So if you want to look at the future species, future pool of species, which will help us to survive or combat climate change, if you have to look at the pool of species, cliff is the best example or best habitat to look at because species are already surviving the higher temperatures and growing there. So various things have been globally people have been doing. For example, our collaborator from Cape Town University, her name is Jill Ferrand. So in the African continent, they have a lot of droughts like us, more severe droughts than us. They have especially the Ethiopia region have their staple food in the form of a grain called teff. So the botanical name of teff is Eragrostis teff, and in addition to this teff which is grown in their farms, they have a wild species of that teff known as Eragrostis natidus, which is a desiccation tolerant grass growing in the wilder landscapes. So Jill Ferrand have recently compared the genomics of wild growing Eragrostis natidus and crop in the form of teff, and they are trying to introduce this desiccation tolerant genes into the crop and to make a crop which is desiccation tolerant. And then you can imagine a crop like wheat growing in our region, and you plant them once and then you don't have to worry about it. It will desiccate on itself, and next monsoon will walk, there will be rain, it will again regreen and start producing grain. So Jill is planning to bring this crop into a reality in another 2-3 years. But people have been globally looking and taking effort to understand how desiccation tolerant genes can help us survive our future crops. So we are thinking about future, and we are thinking about engineered crops. Like you give a list of traits which you want from your crop, and those crops will be in the laboratories. They will be created and given to you. So one such pool of species can help build those crops is this desiccation tolerant plants from cliffs. So in addition to that, why cliff is important, last 10 minutes of my talk before you start clapping. So why cliff species are important is this Douglas Larson book known as Urban Cliff Hypothesis. So he wrote this interesting book, and he says that the human-made structure, the current human-made structure, the skyscrapers we are building, the taller landscapes or towers which we are building with the help of cement and all this material, are actually resembling the natural cliffs. And he says that species like this parva, you know what you call that? The dove, the invasive species. So that pigeon basically, which is associated with our vertical structures, have been creating nuisance in Mumbai and Pune. And the reason why the species is able to survive in vertical landscape, because the species is originally from cliffs. So in addition to that, the geckos, lizards what are found in our house, the cockroaches, the species, the plant species where there is a seepage, water seepage is there on our building. There are species like ferns growing there or some bryophytes growing there. So all those structures are originally from cliff ecosystems. So we have been creating those structures, but those species are trying to adapt those vertical features. And if you want to green, so we have limitations in extending our green landscape in the vertical form because of various limitations of urbanization. But we are already simultaneously creating vertical forms where we can regreen them and bring back the greenery which we have lost due to increased urbanization. One such aspect or one such chance is regreening the vertical landscapes, and which species will help us to survive or grow on these vertical landscapes are basically cliff species. So this is the AI created image. If human civilization vanishes, and what will be the picture after 50 years or 10 years? The prompt was given to AI, and AI created this image. That's going to happen if our species, Homo sapiens, vanish or disappear from this earth because of some reason. So if this is going to be there in next 50 years, 20, 100 years, why not create this today? Why not grow species on the cliffs? And this through this urban cliff hypothesis, we can the building bridges and the walls, as I told you, they are replicates of the natural cliffs. Bring those plants and try to plant them. Do some basic engineering. Do some experiment with those plants and let them grow on these cliffs. So our work, we felt that in our paper we are trying to put that our work will give us a list of species or inventory of species which we can be subjected to various experiments and can be implemented or planted on these cliffs. And globally there are some efforts made by people to make green vertical surfaces. So you also plant various species, the temperature, the AC, electricity bill will also will be reduced, fresh oxygen you are going to get, and a wonderful landscape you can stay. So this is our team basically, which we work. We do collaboration with Dr. Stefan Forensky from Rostock University and our PhD team. Last slide, I would like to thank our director, Research Institute, Dr. Dheeraj, and other faculty members from this college for giving me this opportunity, and all of you for your patient hearing. And as I promised, I exactly finished in 45 minutes. So now I think since I have finished, you can clap. So I'd like to have a few questions if you have any.
Have you done any phenotypic plasticity studies with these plants when they are growing on a cliff location, microhabitat, as well as on the plate habitat?
No, we have not done because we just did some basic study and this was the first work on cliffs. So in future we are planning this. Then thank you very much, madam. Yes.
There are two questions that I want to ask you. One is that the geophytes which you said, they have these underground storage organs by which they can survive the tide over the unfavorable season. But in these desiccation tolerant plants, when they die, or hibernate, just still alive. So the same leaf becomes green again. So how do they survive? So the leaves survive through the.
So there are two ways of doing it for plants. So there are two groups under desiccation tolerant plants. We call them as a poikilohydry. So one is homeochlorophyllus and poikilochlorophyllus. In homeochlorophyllus, they even hold chloroplast and bring down their metabolism to as low as 10%. And sugars play, and then Lea proteins play a very important role in desiccation. So this desiccation is already there in the form of a seed. So seeds desiccate, we know, and then survive whenever water is there. This is a different set of desiccation tolerance which is there in vegetative tissue. So we call this as vegetative desiccation tolerance. So they, because of
this, that means they bring their
metabolism,
like hibernating.
Yes, hibernating as low as 10%. Some species even break down their chlorophyll. For example, these grasses, and then they dismantle the chlorophyll as soon as they receive next shower of monsoon. They first reconstruct the chlorophyll and start photosynthesizing, start greening. So we need a time-lapse videography of some of the species. A few of those videos I have kept on my YouTube channel. So for this, those who hold chlorophyll, homeochlorophyllus species, they become green within just span of 12 hours. So in the morning it's completely dry species, and at the end of the day it completely becomes green.
And then the second question was about the CAM plant. You said that they show CAM metabolism under unfavorable conditions, and then they switch back to C3. So the same leaf?
No. So leaf doesn't show CAM. Leaf shows C3 and the stem shows CAM. There is a distinct spatial separation. So leaves will be present only in monsoon period. So then they can safely undergo C3 photosynthesis. The stem will throughout the year show CAM.
Yes. Because there are various subdivisions of CAM. No? CAM cyclers and facultative CAM and all that. So this must be facultative CAM. But facultative CAM show both types existing simultaneously, C3 as well as CAM. So I'm wondering what subtype. I mean, it's worth studying.
Right. Yes. Okay. There is a video of this Graminoids. Can you just 1 minute video? You can play that. Any other question till that video is played? Graminoids movie. Yeah, please.
Thank you so much, sir. So, does there is any endemism place that you observed specific to the cliff ecology?
Yeah, there are many endemic species that are endemic. They are there on the cliff species. But compared to other habitats, we are less. Just go to like half of the slide. This plant is called as Corallodiscus lanuginosus, which grows on the Western Ghats Cliffs. We just brought some specimens, let it dry, and then subjected. So we started this time-lapse videography at 7 in the morning and kept on watering it till the evening, 7 p.m. It was completely green.
Sir, you were explaining my question.
Yeah. So cliff have some endemic species, but compared to other habitats, percentage of endemism is less on cliffs because it's a very specific habitat. There are there.
Sir, the plant that you observed in the cliff habitat was distributed across, apart from the cliff habitat also.
So we group plants into three basic categories. One is obligate chasmophytes. Chasmophyte is a cliff dwelling plant. One is facultative chasmophytes and one is generalist chasmophytes. So one which are obligatory are exclusively growing on cliffs. The facultative ones are other habitat species, they equally grow on cliffs and plateaus and some other habitats. And the generalist is other habitat species that grow on cliffs. But there are, so grouping cliff plant into three groups help us like to understand which species are exclusive to cliffs, which are generalist, like Aujao, Ghatumara kind of habitat.
So that is fantastic observation that those cannot visit the Western Ghats and all.
Yeah, you are all welcome to visit Western Ghats. We need good volunteers and good people to study cliffs.
Sir, do you find during your study, do you find any ecological threats specific to the cliff ecology?
That is the most interesting question. I think I should have thrown light on this. So cliff is the least invaded habitat of Western Ghats, invaded habitats in India. So you know invasive species or exotic species coming and invading our landscapes. Cliff is such a specific habitat which is least invaded. So you find least number of invasive species growing on cliffs. So one threat of invasion is gone. Then grazing is very limited on cliffs because we have not seen any cows which can grow vertical and eat. But only threat cliff species face is burning, the periodic burning the habitats are subjected. Then that completely destroys the system.
But there is a less chance of spreading as compared to the...
Yeah. Limitations are obviously there in species dispersal.
Thank you so much.
So,
Yes, ma'am.
so is there any similarity or difference in dormancy and night?
Dormancy is often answered.
Usually in microbiology,
Exactly.
what we studied the
Yeah.
dormancy, the vegetative phase of microbes. Whenever get the unfavorable condition, they undergo dormancy phase, and again on favorable condition, the germination start.
Right.
So that revert back to their actual phase.
Right.
So is there any similarity between that dormancy and the cliff?
Yes, I mean even algae they form cyst and unicellular algae or some kind of multicellular algae they form cyst and survive the dry and desiccated period. So it can be called as dormancy, but then there are terminologies overlapping also. Yes, sir.
Not a question, just a query. In the sense, Western Ghats anyway, people know that it is a very hot spot for the biodiversity study, whether plant or animal or study. Now, many people they are studying Western Ghats. Now, such kind of plants are not also available in the Satpura Hills. Satpura ranges are very high.
Exactly.
So, have anybody studied that or
No. We traveled a couple of times to Satpura. Torama, basically, I stayed a couple of days. And we collected some trichomes. And for sure, Satpura will have similar kind of aridity, similar kind of seasonality driven vegetation. So Satpura would definitely have some many other interesting species. And study has not been done.
so please activate some professor from this region to study.
Yes, definitely.
Satpura as a spot.
I'll come and meet you, sir. We can travel also. Yes. Thank you very much.
Okay, I'm thankful to Mandar for showing this particular last slide. There is a student named Smriti and Bhushan. They have worked in this type of situations, and that's why when he said that 90% was a safety, he was making sure that none of his students has fallen down. In Sinhagad, there is a one place called मराठीतनं त्याला कडेलोट म्हणतात आणि कडेलोट म्हणजे अशी एरिया की जिथनं माणूस चुकून सुद्धा जरी थोडा वाकडा तिकडा झाला की लाईफ इज ओव्हर. ओके, सो इट इज as a PhD student as well as faculty, this is an exciting area, but at the same time he has made those skill sets, practical skill sets, how to work on these cliffs. So I'm very thankful for Mandar to initiate such kind of studies, and we'll now stop here this plenary session. We will now go for first lunch break, and we'll We will felicitate Mandar sir with the hands of the awardee man as a token of appreciation for nice session. So thank you, Mandar, and all of you. Now we will take a break of lunch, and then we will get back here at 2:45 for our oral and poster presentation. So during lunch time, at the end of the lunch time, there is the inauguration of poster installation. So all those participants who haven't stick their posters at the poster place, immediately after lunch, please go there and stick your posters, okay? And we will get back in this hall for all our oral and oral session, okay? Thank you.